Interstellar traveler Oumuamua mystery solved. 2017 interstellar asteroid Oumuamua, which means a messenger from afar arriving first, made big headlines because its trajectory violated gravitational laws. Oumuamua on its way out of solar system had a higher than expected velocity, and its trajectory shifted outside of the expected hyperbolic trajectory. Newton's gravitational force F. Oumuamua on its way out of solar system had a higher than expected velocity, and its trajectory shifted outside of the expected hyperbolic trajectory. Newton's gravitational force F, between masses m and m at distance r by formula F equals g times m slash r2, where g is some constant, is responsible for circular and elliptical planetary, and asteroids, orbits, and for parabolic and hyperbolic trajectories of asteroids. Amazingly, the Oumuamua problem is very similar to the well-known Mercury's precession problem discovered by U. Leverrier in 1859 and solved by Einstein in 1915. In Mercury precession without space-bending illusion, we discussed a simple solution for the Mercury's problem. As we can see, the direction of deviation from a classic, in blue, trajectory depends only on whether time ahead of the object slows down or speeds up. If the object heads into slower time, then speed of the object increases compared to the speed by Newton's laws just because of time dilation effect, and the object shifts outside of the expected classic orbit, does not matter elliptical or hyperbolic. In the case of Mercury, slower time happens to be closer to the Sun, gravitational time dilation. Rate of time dilation around the Sun is about 2 millionth, for 1 second passed on the Sun's surface, 1.000002 seconds pass far away from the Sun, for example, on the Earth. But with Oumuamua trajectory there is an opposite and stronger time dilation effect to consider. Time flow outside the Milky Way arms is slower than time flow inside the arms, approximately by the factor of 1.001, see explanation in Chapter 2 of Time Matters. Our solar system is in the Orion Spur of the Sagittarius Arm at the moment, and Oumuamua was leaving not only the solar system, but Orion Spur and the Milky Way's plane as well. Thus, it headed in the direction of slower time with a factor of 1.001, and that factor overpowers 1.000002 time speeding factor, caused by leaving the slower time zone with a factor of 1.000002 in vicinity of the Sun. Time speed / dilation variation caused by leaving the arm, plus 0.001, is 3 orders of magnitude stronger than the opposite effect, 0.000002, on time speed caused by leaving the Sun. Thus, slower time outside of the galactic spur / arm / plane solves the problem of the asteroid's increased velocity and the trajectory shift outside. Gravitational force by Newton's formula does not compensate for the velocity increase. If interested in gravity as time pressure and time as quantum fluctuations, check Simple Quantum Explanation of Gravity Without Mass or Math, and check Chapter 2 in Free Time Matters ebook, also available on Amazon and Google, about time dilation in spiral galaxies.